Welcome. I am Mark Dundas, and this is TechWorks MCIP Series Training Part 4, Programming and API Control. This is where the fun begins. You've seen this slide before, hopefully, because you've seen the other three parts of this. If you haven't, stop now, back up, and take parts 1, 2, and 3 of the training before you continue. This training is for installers and designers, people that are going to be implementing these MCIP systems. By this time, we not only assume that you know what an intercom is, we assume that you have a pretty good understanding of the MCIP hardware and wiring. If you haven't already done so, you should have a system guide handy at all times. So if you haven't, stop now, go download it from our website. Also, there is a presentation guide handout available where you can take notes. And when this is all done, there are certification tests where we authorize people to represent TechWorks with the MCIP product as both installers and designers. Let's do a brief review on how it works. Now, we're going to talk about how a station call proceeds. So this is where an MCIP ODC operator selects a station or originates a call. So there are two types of call. There's the operator to operator when one ODC calls another ODC. And then there's the call where an operator calls a station. And there's two different kinds of stations. There's the typical 25-volt speaker station in a prison cell or that type of application where you have an MCIP 116 that is handling 16 of those speaker stations. You also could have a remote station interface like the MCIP MSI-11, where you have a dedicated speaker and professional microphone because of a challenging acoustic environment and special requirements. So either one of those is what we're talking about. Now, what happens here is the operator desk console wants to talk to one of those stations. So it sends the host an iCall command. That's an intercom call command. The host makes a decision, which is this station available? If not, then send a busy. If it is available, then establish the call. At this point, the host steps back. Once the call is connected, it's streaming audio in both directions, and the call is handled by the station hardware. It's no longer involving any other piece of hardware on the network. So the host steps back and waits for these two to stop talking. When the operator is done with the call, it sends an end call command, which is IEND, and then the station designators to end the call. The host disconnects the call, and that's the end of the story. That's all there is to it. Now let's talk about what happens when a remote station pushes a button. And again, this could be a call button on a 116 or an MSI. Doesn't matter. Either way, station originates the call by sending the host an ICRQ. That's an intercom request. Any station can be sent to any operator desk console in a hunt group. So when you program a station, it can call one or up to 32 operators at the same time with one button push. The ODC selects the calling station, and the call is processed exactly like up above. It's exactly the same thing as if the ODC originated the call. It's just saying, oh, somebody wants to talk to me. So then it goes through the same exact process up above. The configuration is independent for each station. So meaning everything hooked to an MCIP 116 or an MSI can call in to different operator desk consoles, and it can call in differently. And we'll talk more about that. But every station and how it connects to the operator or calls the operator is independently programmed. How it rings, who it rings. One thing to keep in mind is when any station on a 116 is in use, all of the stations in the 116 are tagged as busy. That's because they share a common audio amplifier. There's one amplifier for 16 stations. Doesn't mean they can't place a call. They can place a call. It's just that no one can talk to them. That group of 16 stations is busy. In most cases, that works just fine because an intercom call lasts a very short period of time. We're talking seconds, not even minutes. We're talking seconds that an operator and a station typically converse, and then the call is over. And if there's a call pending, it rings. So that typically is not a roadblock. System wiring and integration of a control system. We're just going to do a quick bit of review. The MCIP is on its own network. So the MCIP intercom has its own switch and its own network. Okay? This is to prevent latency. We do not want audio latency. We also do not want any delays. If you are familiar with what's going on with UL 1069 right now, there was a revision to the UL standard 1069 for nurse call because of IP-based nurse call systems having latency, calls getting delayed, conversations not working correctly. This is all because of network traffic and bandwidth. We want a dedicated network that is unmanaged and uses only static IP, no DHCP. You can have single or multiple IP integration points. You choose. You can have one connection point per property, or you can have one connection point per building. This is all how you design the architecture of your system. The magic happens through our API commands, which are very, very easy, and we'll talk at length about those. If you haven't heard, TechWorks and Omron worked together over a year ago to make sure that the new Omron NX series is integrated fully with the TechWorks intercom. TechWorks, owns an NX series workbench. So we can support you. We have the hardware you're going to install. We can emulate whatever integration you're trying to implement. This integration was done directly with Omron Engineering, and they were kind enough to, in their touchscreen integration, write a help menu. So all you have to do if you're using their hardware and their touchscreen software, hit F1. And there's a whole intercom integration help section that tells you how to integrate to TechWorks. Very, very simple. Let's talk a bit about how the MCIP processes calls and how your programming affects this. So let's talk about a call relay. This is what the telephone industry calls a circular hunt. It redirects unanswered calls to another operator. So there are four aspects to a relay. This is not a forward, this is a relay. So first of all, you have to enable relay to happen on a station. Not all stations necessarily can do a relay. Once you set up the fact that you can do a relay by enabling it, then you set the call timeout, how long you want it to try to ring a station. Then you set the relay 1 location where it's supposed to send the calls if they are unanswered. Then you can set up a relay 2, which is a second operator console that can go to. If it rings the first ODC, then it rings the second ODC, then it rings the third ODC, it will then go back to the first ODC. After the relay, if the call is still pending, it will not necessarily ring the ODC. So in other words, if my call was unanswered at my operator location and went to another ODC, you have the ability to determine whether my ODC keeps ringing if that call is still unanswered, or I can have it so it isn't ringing any longer once it's been relayed. In this way, you could have it ringing at 2 locations, 3 locations at one time, and the first one to get there can answer it, and then it is canceled, ringing at all the other locations. If a call comes into ODC 1 and it is busy, that ODC will not ring. Here's where a call forward is totally different. It's where an ODC is out of service. It's not one call at a time, it's all calls. So if you forward calls from an ODC, you are forwarding all of its calls. Nothing happens at that ODC. It all goes somewhere else. The system is designed so that it will not allow a never answered call. In other words, a circular hunt will circle back, and a forward cannot be forwarded to a place where it can't be answered. If one console is forwarded to another console that's forwarded to another console that's forwarded to another console, the system keeps track of that and says, you got to forward it to some place that can answer. The MCIP configuration utility. This is a Windows program, and this is where all your system configuration is done. This is where you tell the system what to do with every call and how to handle things. This is also what's used to upload your configuration into your host or server to tell the system what you want to do. Now remember, from the hardware section, all your programming is stored in your host or server, and whenever you plug in a box, the host or server tells that box how the system is programmed to be used. Well, this is where you set up the programming, and then you send it to the host, and then when a box is connected to the network, the host sends it to the device. That's the sequence of operation. First thing you want to do is fill out this little screen with your system information. So you got a description, which is a location. You put in the room number, references. Now, you got these 2 little check boxes down below. One says enable API. This allows you to use API commands from a control system for integrated systems. If this box isn't checked, the API commands won't work. Your system has to be told to use these because it takes some extra processing power. We don't want to sit there and waste time processing something that isn't happening. Same thing is true for the NC2 enable. Enable NC2 lets the system know it's got a MCIP 116 NC2 attached to it. So therefore, you have additional programming, okay? If you don't check this box as far as a system-wide parameter, you can't check a box to tell it that a particular 116 happens to be an NC2. So you got to start by telling the system, hey, you got an NC2 hooked somewhere. Later, you'll see it's going to affect how you program individual stations. Next, you're going to click on File and save your project by name. Okay, so you could have multiple hosts in a building, multiple servers in a property, and each one of these is going to be programmed uniquely for that facility. So you're going to want your file name to indicate where this is going. What host is this going into? What server is this going into? The file menu we just mentioned, this is it. It's up in the upper left-hand corner, and you have options of make a new, open an existing, save the one you just put together, Or you can save one that you open. Let's say you open one and you want to save it as a copy. You want to rename it because you like the way you did it. You want the same thing with a couple of changes. Use save as. And of course, exit to exit the configuration utility. The other tab at the top left is options. Autosave is a very nice feature that saves your work in case you forget. Very helpful. The other one is Open Uploader. This is how you open the software update screen to load your program into your hardware. Okay? Before we get going in the programming, there are some shortcuts. One of the neat little tricks that Chris put in the software is double click on a column and it'll activate all the boxes below it. If it's a number, you can put a number in the top box and double click on it, and it'll put that same number in all the columns below it. On some of the functions, there is an all button, and this allows you to activate like all ODCs for a function with one click of a button. On all of these devices, you will see privacy tone. You can activate privacy tone by station. This inserts a tone every 10 to 20 seconds when the station is being listened to. This tells the station, hey, somebody's eavesdropping. Every privacy tone echoes back to the operator, so they know they're transmitting this tone. All of the hardware has a network ID switch, which we talked about in the wiring, because a lot of times when you're wiring this stuff up, that's when you can have the lid off before you put all the connectors on and everything else. That's the best time to set your ID. This ID, however, comes into effect when you're programming. You have to know the position of the ID switch of the box you're programming. Otherwise, you don't know which one to program. Okay? Again, ODCs are going to be 0 through F is going to be 20 through 51. And if it's a 116, your addressing is going to be 84 through 115. And if this box is an MSI, it's going to be 116 through 147. Always try to wear a static bracelet when you're dealing with these ID switches because you are typically inside the chassis. You got your hands on the circuitry. Be careful. So now let's talk about station programming. This is your station programming, not your operator console, but your station programming. So in this screen, you're going to select Station Edit. Next, you're going to select the 116 to edit. See how this says MCIP ID? This would be box 0. This would be box 1, 2, 3, 4, 5, all the way through 31, which is F with the shift jumper in. Okay? Over here, you have a box to check. Are you going to use an external paging amplifier? Again, back to the hardware section. If you have more than a 20-watt load on a particular 116 and you need additional horsepower for paging, you have to tell it. You have to tell it to go get that page amplifier. Go fire the relay and pick up that unit. Send it out the PA bus output so that you can get the amplifier audio out and back for the added power. You'll also see, remember this screen right here on the first slide where you checked the NC2? You'll also see if that box is checked, see how this one doesn't have a second box? If you've got some NC2 hardware in this system, every one of these selections for one of your 116s, you get to tell it, is this one an NC2? If this is an NC2, you get a second set of buttons here. Most of them only have one call point, and NC2 has two. This little drop-down menu determines how you cancel those two calls. You can have it at the end of the call that it cancels the call. You can have it so you have to go to the station and push a button to end the call, or you can have it work from both. So we're still on station edits. We're now on the other half of the screen. We're still on ID 0. This is where the rotary switch is set. Okay. So we're selecting our first MCIP 116. This is the one we're going to edit. We're going to tell it which stations have something hooked to it. So if you've got something hooked to all 16 stations, double click on enable and it'll check all these boxes for you. However, if you've only got something hooked to station 1 and station 6 and station 8 and station 16, then just check those boxes. Then it won't worry about the ones that aren't enabled. Okay. The station ID is just the software guys. It's Chris's way of knowing which point is which. I made Chris add the second thing, which is the station number. This is the port number. This is where you got your wire hooked up. It's the same thing, but Chris calls it 0. I call it station number 1. Okay, same thing. Description. This is a very important part. You can have up to 80 characters in this field, or 40 characters in this field, excuse me, not 80, 40 characters in the field. However, if you are using a TechWorks MCIP ODC TS touchscreen console, this field can't handle all 40 of those because this is the button on the touchscreen. And that button isn't big enough to handle a paragraph. And it'll mess your screen all up if you get too many letters in there. So it handles 2 lines of 7 characters. So keep your label in this description to 2 lines of 7 characters if you're trying to get it to fit on a button. Location, this is for your reference. It might be a cell block. Then a room number might be your actual cell number. This is just for convenience, means nothing to anybody else. Privacy tone, this is where you say, is this maybe a non-convicted inmate and you must give them a right to privacy? This is where you would check this box to give them a privacy tone. And again, it's station by station. Double clicking on the head of the column will check all the boxes or uncheck all the boxes. Privacy tone volume, again, it's set to full volume on the outbound side by default. You can lower this. It's a drop-down menu, and 0 being the lowest, 15 being the loudest. Let's finish the station edits. We're still on the same screen. We're still on unit number 0. Now we're on timeout. This is where you tell the system the length of time this station is going to ring if it's going to relay to another. How long is it going to ring before it gives up and goes somewhere else? Relay 1 is the console where it's going to ring next. Relay 2 is the console where it's going to ring after that. And relay enable is a drop-down menu which tells the system what to do. You have in the drop-down, it can go to just relay 1 only. It can go to just relay 2 only. It can go to both, or you can totally disable relay so it doesn't go anywhere. Ring local is where you tell it, do you want this checkbox to ring throughout the relay process? Meaning, if I've relayed the call from the original operator to the relay 1, does the original operator console keep ringing? Cancel options. This again is a drop-down, and you have 3 options. You can cancel this call at the end of a call, at the station, or at both. This is on a station-by-station basis. So you don't have to have all of them the same. Each station you can do differently. However, again, you can double click on the heading and change all of them at the same time. Now we're going to move to station groups. We're still on MCIP 116 ID number 0, but now we're going to go to the station groups. If this is enabled, it indicates if hunting is allowed for this port. This means that there are more than one console going to ring when this call comes in. So you get to tell it, do you want just one ODC to ring? What's its address? Do you want all ODCs to ring? When an operator at an ODC picks up a call, the remaining ODCs in the group will have the call canceled. So if I ring 4 ODCs, 0, 1, 2, 3, let's say, the call's ringing at all 4 locations. If ODC number 2 answers, it stops ringing at all the other stations. If I want to easily access all, that's what the all button is for. It will literally highlight everything all the way across the screen. ODC common configuration elements. Now we're moving from programming stations to programming ODCs. Let's talk about an ODC to ODC call. Enable makes sure that a particular ODC can or cannot be called. Why would you want to do that? Buy another ODC. Buy another ODC. So if you're a system integrator and you inadvertently program a particular ODC to call another ODC, that ODC could be being eavesdropped on. And that could be totally illegal. It could be in violation of some agreement. You don't know. With an operator, you assume a certain level of right to privacy. So that enable determines whether or not this operator can even be called at all. If you allow calls, meaning enable, you check the enable box. Now you got a choice of auto answer. What does this mean? Auto answer means that that operator's station is turned into the same thing as a remote speaker station in a cell. The operator doesn't touch anything. It just automatically opens up the voice channel and they can talk and you can listen and voila, it's all magic. It's hands-free. If this box is not checked, then the ODC that is calling can't listen to the called station. It appears as a call to that station, just like a station call. And the called operator has to answer that call and use their push to talk button to activate their microphone. In that way, no one can listen to them without their knowledge, and they control the flow of the conversation. Paging. At the operator console, they have 16 unique page zones that they can configure just for them. So no 2 operators have to have the same exact page zones. Even if they share the exact same stations, they can have separate page zones that are unique to that operator console. It can include any combination of ODCs and remote stations, and pages override a connected call. So if you're calling a station and it's involved in an intercom call, that intercom call is put on hold until the page is completed, and then the connection is restored to the intercom call automatically. So let's talk about the ODC configuration screen. Here's the enable button that we talked about. This is the first thing. Is this going to be used? And this is the ID, okay? So the first thing is we're going to enable this ODC, meaning this ODC is connected to the system that has ID 0. Then we're going to add a description. Just like a station description, this is 40 characters. However, if you're using the TechWorks touchscreen, your little console button doesn't have enough room. It's got 2 lines of 7 characters each. Don't try to put 40 characters in there or your screen will become a mess. Title. This is what goes on the top of this touchscreen. This is what you call this operator console. In other words, on the left, you see that I have console 2, 3, and 4. This means that console 2 is available for me to call. 3 and 4 aren't active in this system. I'm console 1. I can put anything I want in this title. If there's nothing in this field, it will say TechWorks MC system. If you fill something in here, it will go right here on this and it can tell you what the rest of the world calls you. Cell block 3, operator 1, whatever you want. Again, it is 30 character field. You can put as much as you want in there because you got a nice big space here. Okay. Room. Room is the actual room number where the hardware is located. It doesn't affect anything. It's simply for your reference. Privacy tone indicates that if someone is listening to you, is this going to have a privacy tone on this station? And the privacy tone level. Every time someone is listening to you, your privacy tone is going to come out of your speaker. We set it at 7. It can go from 0 to 15, 0 being lowest, 15 being loudest. We set it kind of in the middle by default, but you can change it. Forward enable. This is where you determine if these calls can be forwarded. Where can they be forwarded? That's done at your console. But first of all, can these calls be forwarded? External calls means this ODC can get a call from another ODC. If this is left blank, this console cannot receive calls from another console. Auto answer we talked about before. This is where it's hands-free if someone calls you. Let's talk a bit about the display mode. This is relative to our touchscreen. If you're using RTS display, this is a little drop down up here associated with each operator console, and you can determine, is it in normal mode? Normal mode just means you see everything. You got all the functions down here and all your stations here. If you go to simple mode, it just shows you the stations that you have available to you. Not everything in the system, just the stuff that's there. If you go to compact mode, let's say you skipped stations on a 116. What it's going to do is it's going to not show you the stations that aren't active or enabled, okay? And if you go to simple compact mode, it's going to show you only the functions that you require, which are page and other consoles, and it's only going to show you the stations that you're assigned to. So first of all, simple mode, it gets rid of these buttons down here. It gets rid of functions you don't, if you don't have call forward and that kind of stuff, who needs a button for it? Just have 2 buttons down here. If you go to compact mode, it gets your stations down to just the stations that are active, but you might still have these other functions. But in a real simple compact system, you only want to know the stations that are active and the functions that are available. Let's talk about page groups. So at the end of this horizontal row relative to this ODC, we're now at the end under page group. So if you click the edit button over here, it gives you a separate screen. And this allows you to select the page group you want to program. Right now, we're going to program 0. You then get to determine what type of page group. A standard page group will just override intercom calls. An override page will override other pages. This would be an admin priority page. So it's going to block other pages that might be going on. The name of this page group, so you can easily identify it. And you're going to select the stations to include in that group. So on this 116, you're going to click the buttons. If you've got another 116, you're going to click the stations that you want out of that one. You create however many you want. If you want all page, you just hit the all button up here and it'll select them all. You also add consoles, and you can add all consoles or you can selectively page consoles. It's up to you. Station call edits, how a call rings at the operator location. So this is that button up in the upper right-hand corner. Now we're going to click on that. If you've got a standard MCIP 116, its screen is going to look like this. However, if you click that little NC2 button and you've got an NC2 116, this is what it's going to look like. Here's your 16 stations, and here's what you can do with those 16 stations as to how they call in. There are 3 types of calls. You have your normal call. We didn't label it on here because it's a station call. It's the station calls relative to this set of hardware. However, on the MCIP 116 NC2, you have 2 sets of call-ins, which gives you this second call-in point over here. Then last but not least, you have console calls on both. This is how we're going to handle console calls. First, we're going to determine if enabled, if this station is allowed to call this console. Then we're going to make sure that there's a description. This is typically from the previous page. Your call volume is, again, the level that that call is going to ring at. We typically put it in the middle. You can turn it up, turn it down. Reminder means if I'm on another call, is this thing going to give me a tone to get my attention? Or is it going to be silent until I'm done with an existing call? So you can have it make a noise. Ringtone. By default, you're going to get our standard dee-dee-dee, dee-dee-dee. This is a unique tone that communications company came up with years ago for Jack in the Box restaurants or something in the healthcare industry. I don't know what the story is, doesn't matter. But it's a totally unique tone that's very identifiable. If you don't like that and you want to change the ringtone, you can do it. Now, here's the other thing. Realize that these are your stations associated with a particular 116. So what you're doing is you are determining what this particular station sounds like. If you want your door stations to ring differently than your cell stations, this is where you pick the ringtone. It's the same exact settings for all of your different types of calls. So it's the same, set the ring volume, set the reminder, set the ringtone, set the ring volume, set the reminder, set the ringtone. You do it for everything, okay? Again, if you want to check all the boxes at the same time, just double click the head of the column. Now let's talk about uploading your configuration. You're all done programming. You've got all your stuff programmed. Now you want to upload it. You click on the uploader and it loads this screen for you. Now, the very first thing you're going to do is you're going to click on, first of all, you got to be plugged into the network that you're going to load. You can't, this isn't going to do anything if you aren't plugged into the network you're going to load. You're going to select Get System Info. This is then going to populate up here all the stations available to you. Now you're going to come over here and click Import Current configuration from the configuration editor, what you just created. You're going to import it. When you click that, it's going to load it and its file information right here, so you can verify that you got the right file. If there is a match for this file in your hardware list, the hardware that is eligible to load this file is going to turn yellow. It's going to be the host, because that's the only thing you can load a configuration into. Remember, the host sends the configuration to the hardware. So the only thing you can send a configuration to is the host. So it's going to turn yellow. You're going to click on it, and it's going to appear right down here. You then click upload, and it automatically starts the upload process and shows you the progress. When it says it's complete, give it a couple of seconds, because it's got to reboot and reload. It's got to send those new configurations down to your hardware. But that's all there is to it. Let's say we send you a firmware update. Same exact screen, same kind of a process. We send you the update files for ODCs, 116s, host. They are all separate configuration files for the firmware. So first of all, again, you get the system info. So you get your little list of equipment that's eligible. You then go here and click load, and you select the file that we sent you. Now, there will be a file labeled 116. That's obviously for 116s. There will be a file that's labeled ODC. That's obviously your ODC updates. There will be one for host. That's the one for the host, et cetera, et cetera. You load the one you want to upload. You then select the yellow highlighted eligible hardware. So if it's an ODC file that's loaded over here, your ODCs will be highlighted in yellow. You select one, and it'll put it down here in this box. You then click upload, and the process starts, just like anything else. This is the same process whether you're dealing with a host or a server. You're loading this stuff through the host side of a server, not the network side. So this is the host side of a server, or if you have a smaller system, just a dedicated host. Let's talk about servers for a moment. In an MCIP server configuration, you have a server probably dedicated to each building. So over here, I've got this cell block, this building, and it's got its server, and over here, I got this server, and over here, I got this server. Then you tie all these guys together through your network with your touchscreen and all that kind of stuff. Once you have each of the systems configured, meaning you've loaded the configuration in these servers, okay? So you've got an independent working system over here, a working system over here, a working system over here. Now you're going to tie them all together. What you have to do is configure each one of these boxes. And to do that, this is the WAN side of that box. It's that other IP connector. You have to set up all these parameters by plugging in a monitor, a keyboard, and a mouse into each server one at a time. You can do this in the shop. And you configure the WAN port server settings for each box, and you tell each box what else is on the system. The host functions have nothing to do with this screen. The host functions are done with your configuration software, and your host functions are tied to your host port on your server. This is the other port. First of all, you get to set the IP address that you like that's compatible with your network. You set the subnet. You set the gateway. And then you ID this server. So you can have one of 32 servers. They are numbered 0 through 31. You save it. Whenever you save something to the server, it will kind of go numb for a second, because what it's doing is it's storing this information and then rebooting with this IP address. Now, let's go over to the list. This is where you assign these servers to the network and tell the network who's here. So first you're going to tell it, is this server enabled on this network? Is it active? You could have a server that's not on this network and not enabled, not active. Could be enabled. You could have multiple servers not talking to each other. In other words, you could have some talking to one, some talking to another. This is where you determine who talks to who. Once you've set the enable, you identify each IP address. So the IP address you set over here is right here. This is this box. But you're telling it that, hey, you've got another box, address 98, over in the West Wing. Your description is how you identify these boxes. This is just for you. This description doesn't mean anything to the system. It gets all its information off the IP address. Again, you hit save. You're going to go through that same little delay while it puts it away and reboots the changes. The server will automatically reboot on every save and implement whatever changes you make. Now, you've got two more buttons up in the upper right-hand corner of this screen. One of them is a monitor button. This button shows you the status of devices hooked to the network. It shows you everything. It shows you the stations that are active on 116s. It shows you the other ODCs that are available. Don't use this any more than you have to. It's a great tool, but don't leave it running. The reason is it takes a lot of resources and it makes the box get hot. It's great for knowing that everybody's connected. It tells you a lot of information, but don't run it long periods of time. The box will get hot. Page settings. This is where you set up pages across your network. So the pages we set up before were from an operator to its ODCs and that kind of thing. Now what we're going to do is we're going to set up pages across servers. This is different. So here's the screen we're looking at. You create a page group for ODCs across the network. And this is when you're using API commands to initiate a page. We're going to talk about that more in a moment. You have to tell it the server and then the page group within that server that you want to communicate with. So I'm an ODC. I want to page that building over there. I have to tell the system who I am, ODC so-and-so, and then I got to say, I want to do a network page to server number so-and-so, page group such and such. So first you select the page group in this server. Now remember, I'm in a server, so I'm looking at a system. I'm looking at all of my 116s, and I can select any port on any 116. I'm also looking at all of the attached ODCs on this host port of this server, so all 32. I can select any one and include them in a page group, okay? I can repeat this for up to 16 different groups. The PA function is if I want a pre-announce tone. Is there an area, like let's say the exercise yard, that I want a tone to go beep before the announcement starts to get people's attention? You can add it here. It's built in. If I decide I've got this configuration all done and I go, oh, I don't like this, I want to restore my screen to what it was when I booted up, this button allows you to erase your work and log back where you were before. This button is your save. Once you click this, your settings are now permanently changed and stored in this server. This is how you close this screen and get back to your other screen. Let's talk about the API, the external control system commands. The host is able to be controlled through ASCII-based commands sent via the network. So you send these commands to IP address 172.30.100.2, and that is, if you're on the host network, that is the host. Now you're going to tell the host what you want to do. Commands are structured in the format of a command, telling it what to do, the source of the communication, the destination of the communication, and then a carriage return and a line feed. The host then responds to these commands in a structure that's very similar, where it's the message, the response, and then the original command. So for instance, if I send a command that has an invalid command, even if it's a valid station, it'll return a false. So hello's not a command. I typed it, but that doesn't mean it's a command. You send hello, operator 0 to station 0, line feed, carriage return. It comes back and it says fail. It's not going to do anything. Hello's not a command. So let's say I send a valid command. If I send a valid command, the host sends out a reply with an acknowledged response. It could be a busy response. It's going to give you one of two. So let's say an ODC wants to talk to somebody. It sends out I call 09 line feed carriage return, and it comes back with acknowledge I call 09 line feed carriage return, or carriage return line feed. Or it comes back with a busy. It'll come back with one of these two. A typical call sequence when a station presses a button would be ICRQ. That means intercom call request for ODC. This is the ODC number from station number, and this is sent to the host. This would then go to your system where you would activate a button flashing on your touchscreen or something like that. When you select that, then it's going to go back the other way. You can, for ODC programmed to receive the call. So let's say you've got 4 ODCs programmed to receive this call. There will be 4 separate messages. There will be an intercom call request sent to ODC 0, 1, 2, and 3 from station 6, let's say. Okay? The host does all this. It sees one button push and says, oh, I'm supposed to call 4 stations. So it sends out 4 separate text messages to those stations. The ODC then answers the call by sending a I call, that means open a voice channel, please, between operator desk console, that's the number of the operator, and station number, whatever that station number is, to the host. The host then sends back an I cancel to the other stations that were ringing. So remember, we had 4 stations ringing. Only one sent an I call. Let's say it was ODC 0 said I call, open a channel. Then stations 1, 2, and 3 would get an I cancel, which would make them stop ringing. Okay? When the call is then again the host opens up the call between station whatever and the operator based on this I call request. Everybody's happy, everybody else is canceled. Now these two stations are talking. When that's all done, the operator sends an I end from operator zero to station whatever to the host, and that disconnects the call. Servers need a little more information. It's not as simple as an operator, station, and a command. Now you got to identify the command, the what do you want to do? I call space, the source console, space, the destination station, space, your line feed. This is a standard call. This is what we've been talking about up here. Now let's look at a server. The same command for a server requires that you add a console server ID. So you got to identify which server this console is in. You can't just say console anymore because I got 32 consoles potentially on 32 servers. So I first have to say, this is the server that the console is hooked to. This is the console hooked to that server. Now I got to identify the station server with a space and then the destination of that station. Okay, so console server number, the console in that server, then the station server with a space, the destination or station address, and then a space, then your line carriage return and line feed. All these commands are available, lots of them, and there's more coming. Chris is constantly introducing more because we get requests from guys like you. We talked a little bit about I call. We talked a little bit about I end. Here's a bunch more. Like I said, there's even more. You can read about all of these in the manual. But for instance, the first three we talked about, you got an I call, you got a call end, you got a call request, which is a button push. You got a call cancel, which is when the call is over. You also have an M call. That's a master to master. You also have an M end, which is a master to master call end. You have a P call, which is a paging call. You have a P end, which is a page end. You have a forward set, meaning I'm forwarding my calls. You have a forward reset, which stops the forward. You have an I list. These are intercom calls that are active. You can run that report. You can have that if you want it for some reason. You can have a master list. You can get a forward list. You can get a forward not possible list. You can get a no connection possible response. So there's so many things you need to have the manual to understand what all of these do. Let's talk a bit about how you would do a global page between servers. So the command for a global page is GPCAL, global page call. You designate the ODC, the server page group, the server mask, the carriage return and line feed. Broken down, what does this mean? It means you're going to do a global page from this ODC to this server group with this server mask. This is what it looks like. Command, your ODC number, your server page group number, your server mask. That's what a global call looks like. To end it, you have to do the same thing with a GPN command, ODC, server number, server mask, and then that equals a global page end. So what the heck is a server mask? Let's talk about this. Let's do a call for page zone 0 from operator 7 on server X. Don't care what server I'm on, and include servers 0, 1, 2, and 3. So to calculate the server mask, you add the mask value of each of these stations. Server 0 has a mask value of 1. Server 1 has a mask value of 2. Server 2 has a mask value of 4. And server 3 has a mask value of 8. That's 2 cubed if you care. 2 times 2 times 2. You add all of those together, and that gives you a value of 15. So coming from server X, which is not 0, 1, 2, or 3, I'm coming from a different server, doesn't matter what one, my command would be gpcal 7, which that's me, operator 7. I'm going to server mask group, server group 0. So I want to page group 0 in all of these servers 0, 1, 2, and 3. So I put a value of 15 in there. Using the exact same settings, say I only want to send the page to servers 0 and 3. I don't want to send anything to 1 and 2 now. So 0 had a value of 1, if you recall, and 3 had a value of 8. So that would mean that I change this mask value to 9. 1 plus 8 equals 9. That tells it that I'm going to server 0 and server 3. From operator 7 to page group 0, page zone 0, whatever is 0 in all of my servers. That's typically going to be an all call, to be honest. Most people set up 0 as an all call. So if you want to do an all call across the network, you page group 0. Okay? And then your mask tells you who to send it to. And then your carriage return and line feed tell it that's the end of this message. That pretty much concludes this portion of the MCIP training. Again, the website is your best 24/7, 365 resource. There's everything you should need there: brochures, specifications, data sheets. We're happy to help with quotes. We're happy to answer questions. Always easier to reach us for assistance via email. But before you even email, please take the training on the products, have the installation manual handy. We're here to help. We're happy to help. But it's going to be a lot easier to help you if you know the part numbers and you know what's supposed to be happening. Get the hardware. Play with it before you go out in the field. It's always better to do your playing around in private, not in front of your customers. The training and certification for all of our products is online at our website. Click on products. The bottom is training materials, takes you to this page, and all of our training resources are right here. Plus support resources are right here if you need something. You need your systems manual, click right here. It's right there. Okay, it's easy to get to. Help us get all of your staff trained. Get trained on all of the TechWorks products. They're all unique. They're all different. They all are wired differently. They're all programmed differently. No two are the same. That's why we build different hardware for different purposes. Get the salespeople trained so that they can talk intelligently. It makes life easier when they don't ask for one of those red flashing things. We make quite a few red flashing things. Estimators and engineers should take all parts of the training in all categories. That gives them the knowledge to pick the right parts. Certification is there for those that want to represent TechWorks. take all 4 parts of the test. We're happy to send you back a certificate. On those tests, there is a submit button on the bottom. Sometimes it doesn't work. Why? It's a function of your email. Some email clients won't allow that submit button to open an email. In other words, Adobe Acrobat, where you're doing the test, tries to go and open your email client and create an email. And your email client says, nope, that's a Trojan horse and doesn't allow it to open it. It's a safety feature. I turn mine off so the submit button works every time I test it, but it's a security feature in your email. If you can't submit it with that button, just save the PDF and send it to info@techworks-usa.com. Same thing, okay? If you forget that, it's on the website. Just go to the contact us and you can find out how to submit it. That does it for this section. We are always here to make specialized communication easy. That is our mission. Please take the time to take the tests and get certified. Thank you so much for your time and your participation in this process.